This is my second video lesson for Unit 11. In this lesson, we'll be analyzing solutions with different degrees of saturation. Go to page 8 in the class packet. Motivation. Here we have two beakers of salt water. What is the difference between the following beakers? Which one do you think has more salt? Even though both beakers contain salt water, the one on the left looks like a homogeneous mixture, the one on the right looks like a heterogeneous mixture. The one on the right looks like it has more salt because some of the salt is left undissolved on the bottom. In this lesson, we'll be comparing and contrasting these two solutions in terms of saturation. Learning target. At the end of the lesson, I'll be able to analyze solutions with different degrees of saturation. Homework B number 2, which will be a Junipod based off this lesson. Saturation is defined as the degree in which something is dissolved. There are three types of saturation: unsaturated, saturated, and supersaturated. Let's start with unsaturated. In an unsaturated solution, the solvent is dissolving less solute than it maximally can at a specific temperature. This means the unsaturated solution can still dissolve more solute. Therefore, all the solute is dissolved. It looks like a homogeneous mixture. This picture is showing an unsaturated solution because all the solute is dissolved, and if you add more solute, it will dissolve it as well. For a saturated solution, the solvent is dissolving the maximum amount of solute it can at a specific temperature. That means it cannot dissolve any more solute. Since it cannot dissolve any more solute, there will be solid solute at the bottom, and if you add more solute to the solution, it will sink to the bottom. Therefore, the saturated solution looks like a heterogeneous mixture. In this picture, it shows a saturated solution because there's solid solute at the bottom. The third type of solution is a supersaturated solution. That is when the solvent is dissolving more solute than it maximally can at a specific temperature. A supersaturated solution looks like an unsaturated solution. It is also considered a homogeneous mixture. However, if it's disturbed or solute is added, also known as a seed, then crystallization will occur spontaneously. Here's a sequence of crystallization. You first have a supersaturated solution. As you can see from the picture, it looks like a homogeneous mixture. It looks like an unsaturated solution. However, when you add solute, it would begin to crystallize. As you can see here, a piece of solute is being added into the supersaturated solution and will slowly crystallize. Once the crystallization is complete, the solution becomes saturated because there's solid solute on the bottom of the solution. Here's a GIF showing a supersaturated solution become saturated. First, you have a supersaturated solution. As you can see, it looks homogeneous. Then solid solute is added to the solution as a seed crystal. Then slowly it begins to crystallize and become a saturated solution. Learning check number 1. A solute is added to water and a portion of the solute remains undissolved. The solution must be what? Pause the video and resume as completed. Since some of the solute remains undissolved, it must be a saturated solution. Choice 2. This was something that we did last term, the crystallization of copper 2 sulfate pentahydrate. If you recall, we first made an unsaturated solution by adding some of the hydrate into water. Then we keep adding hydrate until the solution became saturated. Then we place the beaker onto a ring stand, and then we heat up the solution using a Bunsen burner. As the saturated solution is being heated, it's slowly becoming an unsaturated solution because the solid that was initially on the bottom is being dissolved at higher temperatures. Then the unsaturated solution is cooled to room temperature, becoming supersaturated. The supersaturated solution is poured onto a watch glass and then it crystallizes. This is the process of making a supersaturated solution and performing a crystallization experiment. Crystallization is a process in which a crystal is formed from a solution. This is the general equation. Crystallization is a special type of precipitation. Here are some examples of precipitation from a supersaturated solution. Here we have some hot soup that was allowed to cool down to room temperature overnight. Notice that in the morning, there will be fat or oil that precipitated on the top. Here's another example. Here we have rock candy, which is sugar crystallized onto a stick. Here's a diagram showing the process of making a supersaturated solution and crystallization. You first start by adding solute into a solvent, forming a solution. Over time, all the solute that you added would be dissolved, forming an unsaturated solution. Then, if you keep adding solute, you're eventually going to form a saturated solution because there's solute at the bottom of the solution. Notice from the diagram, the rate of dissolving and the rate of precipitating is the same. Then you decided to heat the saturated solution, forming an unsaturated solution at a higher temperature. Notice at a higher temperature, all the solute is dissolved. Then you cool the unsaturated solution back to 25 degrees Celsius, forming a supersaturated solution. Notice that the solute is still dissolved in solution. When you add a seed crystal to the solution, crystallization occurs, and the solution is saturated again. Based on the diagram above, how do you make a supersaturated solution? The first step is to start off with a saturated solution. You heat the solution until it becomes unsaturated. Then you stop heating and cool it to room temperature. Now you have a supersaturated solution. Supersaturated solutions are unstable. They will eventually spontaneously precipitate even without a seed. Adding a seed crystal, which is the solute, speeds up the process. Here are some GIFs of a supersaturated solution crystallizing. What is the concentration of a solution dependent on? By looking at the diagrams, it's dependent on two factors: the number of particles that's actually dissolved in solution and the volume of the solution. We will go over this in more detail in the following lesson. Using the diagram 2, 3, and 5, order the following solution by increasing concentration. Concentration is dependent on the number of particles of the solute that's dissolved in solution. Diagrams 2, 3, and 5 are at the same temperature, 25 degrees Celsius. Diagram 5 is supersaturated, diagram 3 is saturated, and diagram 2 is unsaturated. By looking at the pictures, diagram 5 has the most solute dissolved in solution, therefore is the most concentrated, then is diagram 3, and the least concentrated is diagram 2. Why is diagram 4 considered unsaturated and diagram 5 is supersaturated when they have the same concentration? If you notice, diagram 4 and 5 have the same concentration. They have the same amount of solute dissolved in solution. However, the unsaturated solution in diagram 4 is at 100 degrees Celsius, while the supersaturated solution in diagram 5 is at 25 degrees Celsius. So the difference is the temperature. Higher temperature means it can dissolve more solute. Notice when you go from diagram 4 to diagram 5, the temperature decreases. So a supersaturated solution is a temporary state. Given enough time, the solute that's dissolved will precipitate out and the solution will become saturated as seen in diagram 3. Next, we're going to analyze 3 scenarios of unsaturated, saturated, and supersaturated solutions with a solute that's NaCl. Let's look at the first scenario. You add more solute to a solution. What will happen to an unsaturated solution? The solute will dissolve in solution. For a saturated solution, the solute will stay undissolved in the bottom. For a supersaturated solution, crystallization will occur. For the second scenario, the solution is heated. If an unsaturated solution is heated, nothing will happen. The solute will remain dissolved. If you heat up a saturated solution, the solute will begin to dissolve until it becomes unsaturated. If you heat up a supersaturated solution, nothing will happen. The solute will remain dissolved. The third scenario is that you cool down the solution. For unsaturated solution, it would depend. You have to see the solubility curve, which we'll cover in the next lesson. For a saturated solution, it depends as well. There might be more solid on the bottom from crystallization. For a supersaturated solution, if you cool it down, crystallization will occur. Learning check number 2. How would a saturated solution of KNO3 be made unsaturated? Pause the video and resume as completed. The answer is choice 2, you raise the temperature. If you raise the temperature, more of the solute will be dissolved. Describe the effect on concentration if the following happens. Assume the solute is NaCl in the following solutions. You have an unsaturated and saturated solution. Here are two scenarios. The first scenario, you add more solute to the solution. What will happen to the concentration? For unsaturated solution, more will be dissolved, therefore the concentration will increase. For a saturated solution, if you add more solute, it will remain undissolved at the bottom. Therefore, the concentration will remain the same. In the second scenario, you remove half the solvent by evaporation. For an unsaturated solution, since concentration is dependent on the volume of the solution, the concentration will increase. But for a saturated solution, the concentration is at its max. No more solute can be dissolved. Therefore, the concentration remains the same. Learning check number 3. As additional KNO3 solid is added to a saturated solution of KNO3 at constant temperature, the concentration of the solution does what? Pause the video and resume as completed. The answer is choice 3, remain the same. When more solute is added to a saturated solution, it will remain undissolved and sink to the bottom. Therefore, the concentration will remain the same. In addition, the concentration of a saturated solution is at the max already, so adding more solute will not change the concentration. So the answer is choice 3. This concludes the video lesson. Remember to do the Junipod homework.